Today we are designing another water tank in AutoCAD Plant 3D. This time, a 100 cubic meter tank. I already showed one tank design before, but this one will be different. New layout, new approach, and some practical improvements. If you want to compare, I'll leave a link to my previous tank design in the comments. With a 5 by 5 meter tank, we get roughly 98 cubic meters of volume. Now let's adjust the conical roof. When we deal with larger tank volumes, the proportions become very important. If the tank is too tall and narrow, we increase hydraulic losses, for example during filling or emptying, and we may also need stronger walls due to higher liquid column pressure. On the other hand, if the tank is too wide and shallow, we start using more material, especially for the bottom and roof, which increases cost. That's why a 1-to-1 ratio between diameter and height is often the most efficient solution. It gives a good balance. Not too much pressure, not too much material, and overall better hydraulic behavior. The tank shell is complete. Next step, adding the nozzles. The first nozzle is the vent. I'm placing a DN100 nozzle in the center of the roof. While modeling, my mind started flying somewhere else. So I came back and added a ladder and maintenance railings on top. Sometimes you use a ladder, sometimes stairs. It depends on available space and how often maintenance is needed. Just to mention, this tank design is mainly for mechanical structure designers as a concept. We're not going into material thickness calculations or detailed structural analysis. I want to add railings on top, so I draw a circle to give my cursor a line to snap to. Railings on top of the tank are used when instruments need to be inspected. Instead of building a separate platform, we allow workers to access the roof safely. As I tried to do it quickly, now I have railings floating somewhere above the tank. I'll fix that. Be in a hurry, and you'll be the last one finishing. I want you to understand the idea behind this maintenance design. Very often, tank manufacturers provide their own variations of maintenance platforms, so you don't need to model it yourself. You can simply choose what fits your needs: a ladder, stairs around the tank, or a full staircase, with or without a maintenance platform on top. Now let's get back to the nozzles and add one more on top of the tank. This one will be for the level sensor, so I'll make it DN65 and place it on the side of the tank roof. Our nozzle is accidentally flying in the air because I selected too large radius. Let's move it closer to the center and everything will be fine. One more detail. I want this nozzle to be close to the ladder, so it's easier and faster to access during maintenance. Top nozzles are done. Now let's add the emptying nozzle on the side of the tank, DN100. Not too low, because the tank will have a stiffening ring at the bottom. The second side nozzle is for filling. I make a DN32 and place it on the upper part of the tank side. I place it on one axis for simplicity, but in real projects, nozzle positions are often defined by the site layout. The last nozzle is for the manway. I'll just select a generic one from the list and place it next to the ladder. Let's quickly add a vent pipe. And our tank is almost done. No fancy instruments, no hundreds of nozzles, just the ones that are really needed. Now I want to show how I imagine a tank park. It consists of 3 identical tanks connected with maintenance bridges for easy access between them. I slightly rotate the ladders so they are in a more comfortable position relative to the filling and emptying nozzles. Then I copy the tanks and leave about 1 meter of space between them. My idea is to have maintenance bridges on top, so workers don't need to climb up and down each tank. I connect the tanks with small bridges on top, so workers don't have to climb each one individually. Instead, they access one tank and then move safely between them, which reduces effort and improves maintenance workflow. As the tanks are done, I now create a containment bund around them. For water, this is not so critical, but when storing hazardous liquids, it becomes necessary. The containment bund volume should be at least equal to the volume of one tank. That's it for this design. Subscribe for more, and I'll see you in the next one.